Once again, history has been made by NASA with the help of a private spacecraft. NASA and Intuitive Machines launched $120 million worth of climate observatory as a collaboration. But what could this unique mission deliver? Did it land closer to the South Pole than any other spacecraft? What new techniques were applied to make it a better success than all previous missions? You can find it all right here. So give this video a thumbs up, and while you're at it, don't forget to hit subscribe to stay in the loop with the latest updates and breakthroughs in space exploration. Intuitive Machines on the launch. Let's start with a hero of the mission, the Intuitive Machines. Intuitive Machines is a Houston-based commercial private company that gave its all to make this mission successful. They made the first ever lunar touchdown in the 50-plus year history of American lunar exploration. The mission itself is named IM-1. IM-1 has launched a 675-kilogram Odysseus lander through a SpaceX Falcon 9 rocket in space. The spacecraft is carrying 6 commercial and 6 NASA payloads for the mission under the American Space Agency's Commercial Lunar Payload Services contract system. Things got more interesting when NASA planned a new experiment with stereo cameras for lunar plume surface studies. The stereo camera was planted on the base of the hexagonal lander to create 3D images and recordings of the lunar surface. The main reason to blot this surface is to study the reaction of the lunar surface to certain landings. This photogrammetry device will give access to the expert to analyze how this landing will throw the lunar sand around and what possible effect it could have on nearby structures. The increased interest in studying the reaction of coarse particles of the moon to an engine landing is due to upcoming projects, such as the Artemis. The Artemis is the first human habitation plan on the moon, so understanding how repeated landings could affect the environment and the structures around is the first step to making it a success. Other than the stereo cameras, the Odysseus is equipped with another new and promising tool, a new propellant measurement system. This measurement system is created to eliminate any possibility of failed landings due to any sort of fuel issues like many previous competitors. Fuel caused failed landings because in environments with diverse gravity, the fuel doesn't cling to the walls of tanks in random spots. This results in misinterpretation of fuel readings with the traditional methods. It mostly leads the scientists to read nominal readings even when the fuel is riskily low. For IM-1, radio waves and an antenna planted inside the tank will be used in the measuring gauge. Small-scale tests of this gauge have come out as a success on the ISS and zero-G airplane dives. However, IM-1 is the first ever real-world test of this propellant measuring device. Not only for moon landers, but this measuring system could be a huge help in sending spacecraft carrying humans shortly. Currently, IM-1 is more of an experiment to make improvements on low-cost missions, which might shift to a huge project for NASA soon. Moving in the orbit. Now let's talk about the pace NASA launched in orbit to understand how drastically the oceans can change the life we live on this planet Earth. SpaceX launches NASA's Pace Earth observation satellite worth $1 billion on the 8th of February. This satellite was launched on the Falcon 9 from the 4 stations. To be exact, the flight took place from Pad 40 at Cape Canaveral into the polar orbit up to 420 miles from the Earth's surface. The satellite will study the orbit for nearly 3 years, even though the maximum lifespan of the satellite is around 10 years. So it is safe to say that NASA could use it for 10 years if the initial 3 years turn out to be fruitful. If you're wondering why they name it PACE, well, PACE is an abbreviation of all the targets this satellite is supposed to analyze. PACE stands for Plankton Aerosol Cloud Ocean Ecosystem. The system of PACE is equipped with tools to keep an eye on the entirety of oceans. The system is equipped with 3 tools: the Ocean Color Instrument, the Hyperangular Rainbow Polarimeter, and the SPEX-1. The more interesting part is that the system can take expansive scans of water through the Ocean Color Instrument and the Hyperangular Rainbow Polarimeter. However, the Spectropolarimeter for planetary exploration, or SPEX, can capture more specific areas of the ocean in a more detail-oriented manner. As is evident by the names of all 3 tools, they operate by analyzing color or act as spectrographs. Reason to be highly focused on the color gauges is that our ocean and water bodies are highly dependent on plankton. Planktons are microorganisms that are abundantly found to be living on or near the surface of water. The crucial need to study plankton is that the experts are still far away from understanding how water bodies exactly function and affect the climate of our planet. However, they are pretty sure that plankton plays a huge role in the functioning of water bodies. PACE will be able to identify different types of plankton performing different functions just by identifying the color they reflect. One thing about plankton is that it grows on absorption of carbon, but the excess absorption and uncontrollable growth of plankton will endanger the ocean life that humans need to survive, such as fish. But this is different from what experts are most concerned about. Plankton are capable of drastically changing our climate system, and that's where the aerosol feature comes into action. When some bacteria along with plankton consume plant plankton, and as a result release various organic compounds into the environment. These compounds have a prominent effect on how clouds form, and even how storm systems move. Moving along the orbit, PACE will keep track of how these greenhouse gases and plankton affect our climate system, and climate models will be made on the collected data. Collins suit mobility tests. Scientists have been making great progress in advancing spacesuits for the past few years. Collins suit mobility test proves to be one of the great successes in the effort of amending spacesuit techniques. Collins Aerospace and ILC have recently announced the success of a key mobility test with their advanced EVA spacesuit. Collins Aerospace is all set to assist NASA with improving the equipment quality and safety techniques of future spacesuits. On January the 30th, 2024, the test was conducted on board NASA's zero-gravity plane testing vehicle. Zero-G is a transformed passenger plane that is now achieving the no-gravity or weightless effect for testing various equipment, etc. It operates by flying in a parabolic arc up and down as quickly as possible so that the passengers can feel functional weightlessness for no longer than a few seconds. For this specific test, the Zero-G had to make 40 parabolas. The test was mainly performed by former NASA astronauts John Olivas and Dan Burbank. They performed various objective tests while wearing the prototype, such as wearing and taking off suits, moving around, feeling the air pressure, and flexibility of using tools and doing chores, which are needed on missions. The team went further by bringing in the one-on-one scale model of the ISS airlocks to analyze how comfortably astronauts can get in and out of the space station while wearing the prototypes. Fortunately, the testing was labeled as a complete success after analyzing the collected data and doing a comparison with NASA's current EVA spacesuits. The Collins and ILC are expected to hold more tests in NASA's pool at the Neutral Buoyancy Lab. Luckily, we don't see any issues with Collins and ILC going further with NASA, since ILC Dover has already been a great partner to NASA. ILC Dover was the first to create an EVA suit for the Apollo program. Even the current suits that ILC Dover is trying to replace for NASA were designed and created by ILC Dover. The reason is that ILC has moved along numerous technological advancements and amended ideas to deliver better than ever before designs. Recently, the main focus for NASA and ILC Dover has been to crack through with spacesuits that fit a wider range of body types and overcome serious issues like highly limited motion within the spacesuits. The development of these advanced spacesuits by Collins and ILC is not only for space station use, but planetary EVA suits as part of the $97 million Exploration Extravehicular Activity Services contract that they achieved 2 years back in 2022. Axiom Space is another company designing the suits alongside ILC and Collins. However, Axiom decided to design their planetary suits first. After completion of designing and developing these suits by both companies, NASA will choose the most suitable one to finally replace the suits designed almost 40 years ago. The world of space exploration and inventions is nowhere near shrinking, but only expanding. So you might want to hit subscribe to stay updated for all the future advancements in time. Leave a like if you found this video interesting, and comment what is your take on these rapid developments as well.